perspective on the evolving industry landscape. Another special feature of today's session is it will be moderated by our younger alumni, Mr. Darun, a third year chemical engineering student of NIT. It is heartening to see our current students and alumni coming together through this initiative, making Recall bond stronger with every interaction. Your feedback is important to us, and please do give your valuable and feedback by reaching out to Recall. I encourage everyone to actively participate, engage with the speaker, and make the most of the interactive Q&A session. With this, now I have the pleasure of handing over the floor to Mr. Darun. Over to you, Darun. Thank you.
Thank you, sir. Good evening, everyone. First of all, I would like to thank Recall, the Alumni Association of NIT Trichy, and the Student Council of NIT Trichy for giving me the opportunity to moderate today's session. It's a truly privilege to be part of this event. And now it's my privilege to introduce our guest speaker, Mr. Brinjit Velu. He is an alumnus of 2000 Chemical Engineering batch and at NIT Trichy, currently an enterprise architect at Merck KGAA Global Capability Center, Bangalore. With over 2 decades of experience spanning engineering, digital transformation, and enterprise architecture, Mr. Brinjit has successfully bridged the gap between chemical engineering and technology. Today, he'll be sharing his insights on evolving chemical engineering and the exciting opportunities in IT and oil and gas sectors. With further ado, I'd like to invite Mr. Brinjit Velu to take over the session. Over to you, sir.
Thanks, Mathivanan sir, Darun, Shilpa, and Ganesh for helping with the organization of this particular session in particular, and also inviting me to address alumni of our esteemed institution, both students as well as people working in the industry or in the education side, or those who have also retired. But truly privileged to invite me for this. I'll just proceed now with my presentation. Let me see, where is the... Okay. Let me know when you are able to see my screen. You're able to see my screen, right?
Yes. Yes, sir. Visible.
Okay. Okay. So, as far as I'll also like to give a brief introduction of how my career has actually progressed over the years. So, as already introduced by Mathivanan sir and also by Darun, I'm Brinjit from the batch of 2000 BTech Chemical Engineering. So, after I graduated, I joined Thermax, Babcock and Wilcox in Pune. So it's basically a mechanical engineering company. Technically speaking, they manufacture power generation boilers. So they have actually started their Indian operations back in 1973. So we had a lot of people from across the country, esteemed institutions, including NIT Trichy, and we were like 3 people who had joined. One person from mechanical and 2 from chemical engineering. The person from chemical engineering, aside of me, he actually went on to pursue his master's degree, so he technically didn't join. But I just want to, in fact, even give an overview of how my initial experience right after graduation was. So, there, if you see, as far as what you actually learned during your course curriculum and what you end up working in, there is at that point of time I had seen like the gap was fairly significant. So um, you would actually end up spending like close to around a year or so just to you know, get a grab of the roles and responsibilities that you are going to be working on. And yeah, so it was pretty eventful that way. Yeah, so as you can see on the screen, like I'm just also giving an overview of like how chemical engineering processes have evolved over the years. So coming to my time at Thermax, right at that point of time, like wherever Thermax had actually supplied their power gen boilers, uh, the customers were like pretty much having their SCADAs or programmable logic controls, PLC machines. They were all like fairly manual driven, push start process equipments. And then even back then, like if there were certain data that needs to be collected, you know, from point of view of research and development, those were all documented in Excel for processing. So, and that's how things were being stored. Luckily, at that point of time, it was not like as though we were storing a lot of data in big booklets or files or things like that. But then still, we would take a lot of industry data and then we would print it in like big booklets and then we would store them for a specific project. So at any point of time you wanted to in fact even refer any of the data related to a specific power boiler, we would just open it up, try to refer it, check the process and instrumentation diagrams and things like that. Many of the pressure control valves also which were being used back then were like fairly manually operated. There were of course pressure control valves and all that that were also automatically controlled from the control room. But yeah, I mean that transition was just barely beginning at that point of time. So that also meant like to manage the show, we actually had to have a lot of technicians and gradually over a period of time things were automated. Okay, so like I mentioned earlier, many of the data related to research and development were all stored in structured formats, Excel sheets, or probably stored in the form of tables and views and all that in the database if they are stored there, or else like basic Excel sheets, or if there was like documentations or manuals and all that, they were just stored in folders. So this is how things were. And there, it was also very cumbersome in the sense like what would happen if one of those systems where you're storing this, right, it just crashes out of the blue. Back then, crashing of desktops were like so common. You know, there was no backup strategy or things like that. So yeah, when gradually we started, I mean, like when I actually went on to pursue my master's at Texas A&M University in College Station back in the US. This was like 2004 to 2006. At that point of time, for our projects and things like that, we were also using Excel programs, you know, the largely macro-driven programs. We would write in the back end, and then yeah, you would get a flashy. You would just feed in few parameters, and you would get the output. You can probably get some sort of graphs, things like that, you know. So and just to in fact even give a feel of like where I was coming from, I was in fact apprehensive of in fact even Word and Excel and PowerPoint and things like that. PowerPoint I didn't in fact even work back then, and this is I'm talking about like 2003 or so. But yeah, Word and Excel were something which I was just getting familiarized with, not exploring the features that Excel had to offer at that point of time. Okay, a lot of those basic functions that you could see even now, they were just being introduced into Excel at that point of time. Okay, so then gradually, like what happened was like after I finished my master's program, I went on to work in the oil industry, basically a service-based company called Baker Hughes. Yeah. So from Houston, from our headquarters, we were actually being deployed into uh, various sites wherever we had to actually provide our service, oil and gas field services. And I was actually deputed in New Mexico and then eventually into Colorado. So that I worked for like roughly around a year or so. But yeah, I mean, the work even back then, like mostly were fairly, I mean, even if we gathered a lot of data, right? I mean, most of the tools that we were actually using were industry specific ones, and those were not AI enabled. But like over a period of time, what I have generally observed is the technical stack started moving from the quintessential usage of physical hardware storing data on your big servers or folders, structures like that. Storage units started coming in. We started using virtualization, VMware. So with that, like we would have physical hardware was in the backend, but then the infrastructure teams could actually spin up server clients systems and things like that. They could set that up. They could, in fact, even create databases and all that. And they would just hand it over to you depending upon whatever configurations you would have from a network point of view. So this is how like, and I mean like from like maybe mid of 2010s, like 2015 onwards, we started hearing a lot about AI enablement of the IT tech stack. So that actually meant whatever data was actually accumulated over a period of time, right? I mean, say maybe 2000s or so to 2015, like 15 years of data, sometimes even like data from like mid 90s. So there's like already detailed significant amount of data that we have accumulated over the years, and then we started building in the AI capabilities linked to it. So I saw finally that it was at the beginning it was mostly IT tech stack, but now like I'm seeing, in fact, even many of the industry specific tech stack, right? I mean, be it for chemical or mechanical or electrical or instrumentation or process control equipment, they do have their AI variants as well. So this evolution is happening. It was not sudden, but then that was something that happened over a period of time. So back in the day, most of the data that was being consumed were by decision makers, people at the leadership level. But then now, of late, like people who are plant engineers, production plant engineers, lab technicians, research scientists who are doing material simulation and all that, they are also consuming quite a bit of data and increasingly want to also start leveraging the capabilities that AI has to offer. So next in line basically is the integration of this operational data and IT. So I'll just stop here for now in case somebody has any questions. You might want to mute before you.
Yes, sir, I have a question,
Yeah.
which most of the audience will be interested in also.
Okay.
So many of us are still learning traditional chemical engineering concepts. So
Yeah.
how should today's students be strengthening their core fundamentals while also preparing for rapidly evolving technologies like AI and also?
Okay. Yes, I would say like people who are like seriously determined to actually pursue a career in like core chemical engineering area, or like probably maybe a slight variant, maybe moving into the oil and gas industry, be it on the downstream side or the upstream side of things. I think like you should just concentrate on strengthening your basics as such, as far as the course curriculum is concerned, because that is going to be like the benchmark from which you can actually move forward. That is just basic knowledge. But then that is something like which you definitely need. So please do not ignore it at any point of time. Alternatively, there are also, I believe, even back in the day when I was studying, there were also certain courses from a pure sciences perspective, like maybe organic chemistry. In organic chemistry, back then we had courses, and then in addition to that, also some IT programming uh, um, courses as well. So I would say, depending upon what you actually aspire to do once you graduate, I think you should uh, start looking into each of these areas, because I don't think by any means you can do core chemical engineering or oil and gas stuff without knowing a little bit of IT. Likewise, the other way around is also important. Like for people who are like purely working in the IT industry, um, people who are working in the IT industry, right? I mean, they also need to know the business side of things. Unless and until you know the business side of things, you will not be able to resolve the issues that the business has required, asked you to resolve for them. So it is very important to, in fact, even have a close interaction between IT and non-IT at any point of time. Does that answer your question?
Yes, sir.
Okay.
Thank you.
Okay. Right. Yeah. So then, general misconception that I have amongst people in general is that AI is here to cause a lot of disruptions. People are losing jobs like never before. Uh, this is only just partly true, I would say. Okay, because by and large, it is also an indication that we should adapt to the changing time. That's basically some sort of signal. We would need to adapt ourselves to the advancement in technology, and this is not limited to only just IT, but also non-IT. Okay, so this is very, very important, I would say. Um, and then the other part is like most of the processes are not like completely end-to-end driven by AI. It would still need some sort of interventions from time to time by personnel. At least you would need people who have actually built the processes in AI in the first place. So that is definitely required. And at the same time, it is also very feedback driven. So if there are certain processes that are that are something that need to be still rectified, and AI needs to amend itself to make it more accurate, I would say, yeah, I mean, a lot of data interpretation being done by these AI systems have to be more accurate. So from the production plant perspective, I have actually seen that new initiatives like predictive maintenance and then these manufacturing execution systems, they are being optimized. They are being automated to improve the performance of these equipments and make sure that they deliver what they are actually meant for. And at the same time, as far as predictive maintenance is concerned, you need to also take proactive measures to ensure that the maintenance and overhauling and replacement of these parts are carried out before you actually face a major breakdown. So, because these equipments are also subject to wear and tear, and there is a certain warranty linked to each of these. So, over a period of time, many of the tools also have AI capabilities linked to them. So, while it is still true that we have quite a distance to actually traverse as far as bridging the gap between IT applications and also the operational technology applications. I can say for sure with a lot of conviction that gap is actually narrowing as time passes by. Okay. Then probably the other part is like hazardous chemical handling. I mean, people who are working in the chemical industry and also who are working in the oil and gas industry. I mean, you are actually exposed to quite a bit of hazardous chemicals and all that. So from time to time, in fact, even you also have to undergo quite a bit of health checkups and things like that. We have to take care of the environment as well as far as safe disposal of all these uh, chemicals or parts or effluents are concerned. So those kind of things are there that are also subject to a lot of laws, policies, and protocols. And we have to bear in mind that the workers at large, the public who live in the vicinity of the industry, and the environment also that they are exposed to, that has to be fairly healthy as such. So a lot of regulations, a lot of regulatory procedures are there that industries are often subject to. And AI, while it can be used in many of the areas, there are also restrictions to which AI is subject to, like, for example, data privacy, handling of personally identifiable data, like one's medical health issues, or like, in fact, even related to affiliation to trade unions or political affiliations and things like that, right? These are all very sensitive data. So for all these things, right, I mean, there are regulations, and by and large, there is a limit to how much you can actually leverage AI. Okay, and then last but not the least, intellectual property and patented data, right? Very few people in the organization will be having that access to. So again, when it comes to things like these, there are AI regulations also for certain geographies. I know for sure, like in North America and European Union, and in fact even in the Far East, there are AI enablements and all that for restricted data. The reason for that being, like, if this data gets leaked, then there are like severe criminal and civil penalties that the organization is subject to. I'll stop here for questions from the audience.
Yeah. Brinjit and Tarun, can I ask a query here? So from the chemical engineering side landscape, how robust is the startup scenario? I mean, we know a lot is happening on the IT, electronics, semiconductor side, right? How robust and are more people jumping into conventional, traditional chemical engineering domain into startups as well?
Yes. So by and large, what I have not seen. My exposure is more towards organizations based either in the US or probably more in European side. So what I have generally observed there is, like, there are companies that are actually providing services to clients across the globe, and they are more into like pure sciences. I'm pretty sure there would also be chemical engineering related startups as well, but they are more like disruptive, I would say, and they have something very they have something extra to offer than conventional chemical engineering startups have to offer. In some case, I have also seen situations where, in fact, the softwares that they are offering, right, these chemistry and chemical engineering companies that they have offering, they already started offering more cloud-based applications from their side, and this was back in like already in the late 2010s, like maybe 2016, 2017, 2018, and all that. So with that, we also saw an evolution of the other cloud providers as such, like AWS, Azure, Google Cloud Platform, and all that. So there was generally a apprehension of whether their data is very secure or not. So many of the people started still restricting themselves to the conventional IT landscape, like having physical servers setups or maybe virtual machine setups, and then storing it there. And then they would have like all this data encryption and things like that related to it. But now, like I've seen increasingly also the chemical engineering and also chemistry companies focusing more on selling products which are also AI enabled and also having compatibility with cloud. So yeah, this area is actually evolving also. So like I mentioned in the previous slide, right? I mean, it is not limited to only just IT, but also the traditional non-IT engineering industry is also evolving, and their products are also becoming more, what is it called? Um, they're coming into a situation where the integration of the non-engineering data with engineering, non-IT engineering data is getting integrated with the IT side of things. So the IT folks are actually trying to connect more with the business side of things.
Okay.
Brinjit, I have a question.
Yeah.
I think it is very fair to say on the chemical engineering front, we have already used knowingly or unknowingly the so-called some of the salient aspects of AI. When I say that, I'm talking about things like supervised learning, unsupervised learning, reinforced learning, everything typically in a petroleum and petrochemical, industries where we have this CADA systems and dedicated, panel mounted systems.
Right.
We have seen what do you call a kind of a big leap in terms of the transformation from where the industry was like 30, 40 years and now where we are today because of the promulgation of the AI soundingly. Having said that, are there any LLMs or SLMs which are being developed or probably already in place to capture, the major standards like, for example, ASMEs, PSPG, WM, and all those kind of stuff, right? So that, it will be very much beneficial for the, the budding engineers, chemical engineers, and also the young alumnus to explore opportunities, avenues in those areas also.
Mm-hmm. Yeah. I mean, I would say still there is quite a bit of work remaining to be done. I mean, I would say it's just like, it has like just begun, I would say. The integration is not complete. I mean, it will take quite a bit of time because from what I've generally observed is the traditional engineering ecosystem is still a little reluctant to change. But the thing is, when it comes to actual decision making, right? I mean, many a times what I have generally observed is that the people who are in the leadership, they want to actually have a lot more exposure to industry data before they can and try to make an assessment of how to actually manufacture things at scale. Okay, because I mean, I can give an example of our IT industry, of the chemical engineering industry itself, right? I mean, from as far as downstream petroleum is concerned, right? I mean, when it comes to refineries and things like that, what I have observed is we are right now like the number 4 uh, as far as refining capacity is concerned, India. But we do not have many refining capacities, many refineries outside of India. And I think, like you might have heard in the news, that I think Reliance is trying to set up a big refinery in Texas near the Gulf of Mexico. And that will actually be refining huge quantities of oil and gas. But then the thing is, the biggest challenge that we have is producing at scale. I mean, same is the case even when it comes to actually performing experiments as far as the semiconductor industry is concerned, because that is also an area where a lot of research and development is performed. But then the thing is, the biggest challenge is manufacturing at scale. And the need of the hour at the moment, again, in fact, as far as semiconductors are concerned, there are very few companies that can scale to the capacity of probably even a TSMC. TSMC is by far, I think, manufacturing close to around to 60 to 70% of the chips that the entire world actually is using in various domains. Yeah, I think Senthil Kumar has a question. VSK, I think.
Yes.
Yes, VSK.
Yeah, am I audible?
Yeah, I can hear you loud and clear. Yes, go.
Yeah. First of all, I'm really happy. I also learned something. So I'm curious to know. Earlier we heard about IoT, Internet of Things. Then later IIoT. Now people are talking about digital twin. So could you tell us, because though I'm not from chemical background, you people involved into process, chemical plants and everything, how these technologies are trying to help us, isn't like digital twins, AI enabled. So could you share some experience comparison with Western countries, US and India?
I think even India is lagging far behind as far as usage of IoT or AI is concerned. I mean, it is just now that we are in fact even waking up after a long time, but at the same time, we are just trying to build AI data centers. That's it. We do not have AI capabilities built in like significantly. There are only just, I can say, pockets where we can in fact even see people using AI. Maybe to an extent, from what I have seen is maybe to an extent as far as this automobiles, and then probably I mean, very limited, I would say. There is a limit to as far as AI is concerned. It's a little sad, I would say, but yeah, I mean, it's about time that we actually leverage this. In fact, Government of India is also trying to leverage this, and I hope with that in mind, we can get a lot of work coming into the domestic IT service companies, all these big companies, right? Like TCS, Wipro, Infi, HCL. They can actually help the Government of India with various things. I mean, AI can be used, God knows, in so many, probably the biggest employer the world has probably ever seen, that is Indian Railways. Badly needed, right?
Yes.
So, yeah, I mean, we have a lot of avenues, but we are yet to tap them. We are just busy serving our clients across the globe.
I will add a point. Mostly we want government funding. So we need some private players also to come and participate and invest small amount of money to see. So this is one humble request. I don't know, like this is the appropriate forum. So I'm expecting maybe some private player will come and pitch into this.
Yeah, I can tell you how things are. I would have had a lot of one-on-one discussions with you also in the past about this. See, government funding is very, very limited. I mean, there's only to an extent that government can help for things. But what is lagging in a big way in our country is industrial participation. Like, I don't see industries tying up with big institutions like IITs and NITs and probably the big engineering institutions the country has, right? It's a big opportunity for us to, in fact, even build things for our own consumption itself. Do a lot of research. I mean, I think, like, in fact, for example, this ethanol blending, right, that we have with petrol, and then also isobutanol blending with diesel. These are all like key areas where we actually have to do a lot of significant research before we actually, in fact, even start going ahead with blending. Because at the moment, what you're seeing is people are complaining about their vehicles, and some part they have engine issues, efficiency has gone down, and things like that. So which is sad, right? I mean, that's a clear indication that there is no research and development either by the auto industry, or they have not, in fact, even probably outsourced it to big institutions that we are having, right? I mean, we have a lot of intelligent people across the country. I mean, we are a country of like 1.5 billion. And if we are not able to, in fact, even do extensive research before introducing a product, it's disappointing, I would say.
That's a gray area, Khalid. Thank you.
Okay, so then, like I mentioned right earlier, we were talking a lot about AI and data, digital, not just the IT applications, but also the operational technology applications across various streams that are actually having their AI component linked to it, because they have to either improve their productivity or they have to focus on maintenance or optimize performances and things like that. But then the thing is, like, just merely adopting this AI and data and digital tools is not bereft of challenges. There are a lot of challenges, and the main thing is cyber attacks. You would have seen you would have seen it in the news for, I don't know, like probably years, or probably, in fact, even a couple of decades, that there are cyber attacks in Russia, or there are cyber attacks in China, or there are cyber attacks in, I don't know. It's just all in Europe, or probably in North America. This is a challenge that probably all industries have to overcome. And with more data, it is just giving that much avenue for cyber thieves, right, to steal all that data and make money out of it, try to monetize it for their own personal benefit, right? With that in mind, like, we have also come up with so many other protection mechanisms, like usage of passwords, using complex passwords, or using like multi-factor authentication. And now we are using pass keys, which are like limited to, dependent on the device that you're actually making use of, as far as accessing various applications or things like that. And then the other thing is biometric data. So this data also, again, there are people are actually getting smarter. When I say people, it is cyber thieves. So we have to always be a step or two ahead of them. Okay. So as you can see down, these are all items that we will have to bear in mind when we are trying to integrate the IT as well as the operational data together. So one is like supply chain risk management, then governance, like already data that you are storing for your own company's benefit. That is also, you might have to restrict data. You'll also need to ensure there are proper setup for backup and recovery. If you lose data, like say if you had a crash right now, you need to probably restore the data to maybe around 10 minutes back or 5 minutes back. That is possible provided that you have like primary, secondary setups as far as your data centers are concerned, and you can in fact even recover it quickly. That was not the case probably if you can say maybe around 20 years, 25 years back. So this backup and all that is badly required. And then the other part, like everybody are talking about learning cloud and AI and things like that. But then again, there are also cloud security related parameters that you'll have to bear in mind. Network security, because you're actually transferring data over various communication layers, so network security, access control, physical access, physical devices that you are actually making use of, USBs, mobiles, and then in fact even your desktop and things like that. So physical control, physical access control is also required. Then even something as basic as emails, especially when you are transferring secret data or like confidential data, then you will need to have encryption, right? Email encryption. So those kind of stuff. And then in addition to that, like when you are storing data either at rest or when you are transferring data across layers. So encryption at rest and in transit, these kind of things. Then in fact, also your antivirus, endpoint protection, event management in case there is a cyber attack. People who are actually in the first line of defense, they should actually get an alert that there is a cyber attack and they'll need to take precautions to actually block privileges or try to identify where the cyber attack has occurred and who has tried to breach it and things like that. So, and then in addition to, and last but not the least, you have a lot of market regulatory compliance that you will have to deal with. So whether you must have heard about GDPR, HIPAA regulations, NIS2, which are all specific to certain security protocols. Okay, and then last but not the least, in fact, even companies are also subject to periodic audits. Yeah. So yeah, I guess that was pretty much it as far as the presentation is concerned. You have any additional questions? Probably it'll be a wise idea to actually go through the chat that people have.
I have to give you Thanksgiving.
Oh, okay. Yes, Vimal. Hi. I think you might want to unmute. Yeah.
Yeah, hi. Hope you remember me. We talked.
Yes. I do remember. Thanks for joining.
Yeah, I was actually excited to for this meet with you. So my question is actually I'm really interested in the current ML and Gen AI thing, and in fact I'm actually interning in that area. I'm actually doing an R&D work in that area, the essential. So and I'm also like since my second year I've been like curious about this pharma, and I have seen a lot of job posting like from Eli or Novartis keep emphasizing on pharma. In fact, I think pharma industry is the one of the early adopter of AI. I would say in the terms of research field. So, do freshers have a scope in there?
Yes.
R&D part from a career perspective.
Yeah. So since you are already doing AI and ML, right? I mean, many industries are using it, but then you are right. I mean, the healthcare industry as such is one of the early adopters of AI and ML, and they want to leverage the use of AI and ML as much as possible. I can give you a big example, and that is more to do with research and development. To actually introduce a drug into the market, because it has to actually undergo a lot of tests, preliminary tests. They'll have to test the drug on microorganisms. Then they will go into they will test on rats, and then eventually they will have a controlled test on few participants before they can in fact even introduce, right? I mean, that cycle as such is very lengthy. It's long. It sometimes takes almost 10 years to actually introduce a drug into the into the industry, into the mainstream market as such. So exhaustive studies are there. So that is why, like I mentioned, right, Vimal, in one of the slides, that it is very important for people who are working in the IT side of things to, in fact, even know how the business works. So when I say business, there are also different departments, right? R&D is one of them. Manufacturing is another, and then likewise you might also see sales, marketing, and sales. So yeah, it's an evolving field, I can say.
Okay. I just want to know, like, as a fresher, like I'm a fresher out of my college, would it be possible for me to, get into the R&D field of that? Like, I'm a chemical engineer, but working in a ML part. Is there like any, previous tracks in the company? Say you are working in the milk, right? So you might have seen few people in there. Is it like, do they hire a chemical engineering fresh graduate, especially from UG?
Yeah, well, I mean, what I have generally observed are people who are from pure science backgrounds or like bioinformatics who are actually working purely into R&D, because there are certain things which they have deep knowledge in, like for example chemistry and all that, right? Organic, inorganic structures and things like that. I know there are certain courses within chemical engineering also that cover those areas. It's not like as though there are no chemical engineers who don't follow that particular path, but they are less, I would say. But having said that, like if you have already worked in um AI and ML, it actually makes a lot of sense for you to, in fact, even assist research and development engineers when they come across certain things um, related to the data that they are actually working on, right? So it becomes a lot more easier. So the connect between the IT and um, the core area, right? I mean, be it uh, pure sciences like chemistry or uh, bioinformatics, I would say, and then also chemical engineering, especially we're working in chemicals, more chemicals. So um, yeah, or if you're working in hazardous handling of chemicals and all that, right? Hazardous operations. So yes, there are avenues that I can say. Yeah.
Okay.
Yes,
Thank you.
Mathivanan sir.
Thank you very much.
Yeah, so I mean, the previous person who raised a question on AML and combining chemical engineering stream for job opportunity. I think there are companies like Equia, right? Which are into healthcare consulting, right? And
Yes.
they need a domain expertise in
Expertise.
areas of
Yeah.
pharma and research and R&D and all that to kind of have their projects done. And I think those kinds of companies, I mean, on the management side, you have the big fives. Likewise, domain-specific companies like Equia, which are bioinformatics, healthcare consulting, pharma, touching on pharma and all that. I think those could be also avenues for career options. Is what.
That is very true, Mathivanan sir. You're right, absolutely right. The thing is, like, there are positions which I actually expect, especially senior level positions, right? When you have like around 10 years, 15 years of experience, they expect you to understand business language more than IT. IT, yes, of course, because you have worked all this while by then in IT, but then they also expect you to understand business language. So it can be especially healthcare related, like you mentioned, right? Giving an example of IQVIA or maybe Eli Lilly. Yes. So that is, I mean, in fact, apart from that, like various regulations that are linked to the healthcare industry and all that, right? Knowledge and awareness on that, or in fact, even the cyber security practices linked to it. All of this, I mean, they actually expect people to be more all round, I would say, rather than somebody who is who is a specialist. So the specialist roles in general are something that are actually evaporating over a period of time. So you need to be somebody who wears multiple hats.
Okay, thank you very much, Brinjit and Manivandan.
Okay. Any more questions?